Hello, this is a hint video for problem number 1A on worksheet 3. The first thing you need to do is basically follow these directions up here. And the first step is to identify all the objects that are going to be in your system. Now, they tell you what's in your system for problem 1A. In future problems, they won't tell you, and you'll have to kind of figure that out and determine what's in your system. But that shouldn't be a problem. So we put here all the objects in the system: car, track, spring, and earth. And then we ask ourselves, where is the energy to begin with? And so we want to go ahead and describe the energy types and the amounts in at position A, and then later we will do the same thing over here for position B. So position A is like the initial state, and where's the energy? Well, it is all tied up in the spring, and that would be elastic energy. And so we go ahead and decide how high to make this bar for elastic energy. Now, this was decided to have it go up to 5 bars, and that's fine. And so we have all the energy and elastic energy, so we make our bar like that. Now we need to also consider for the final state, or position B, where did the energy go? And one thing we need to keep in mind is the law of conservation of energy, which is the first law of thermodynamics, which states that the total amount of energy cannot be created or destroyed. It can be converted to different forms. And so if we start out with 5 bars of energy to begin with in position A, we have to make sure we have a total of 5 bars afterwards in position B. And so we see here, and think about this for B, it's moving, so it has some kinetic energy. We also see that it is above the 0 gravitational position. And so it has some gravitational energy. And so we decide basically how to break that up. So in this answer key, it was decided to have 4 bars worth of gravitational and 1 bar of kinetic for a total of 5, again, abiding by the law of conservation of energy. Now, one other way we can write the law of conservation of energy is through an equation. And so we see that the starting energy, elastic energy, equals the sum of the ending energies, Ek plus Eg. And this is the beginning of coming up with equations to eventually solve problems quantitatively.